Okay, today I'm going to cover regular expressions, which are very useful and indispensable. You can't really do much without them, especially when it comes to web applications and processing and validating user data. You're going to need regular expressions. Know how to do that. You may have worked with them in other languages, and if you have, most of this will make a lot of sense. Especially JavaScript has support for regular expressions. PHP does. Pretty much every programming language does, including, I believe, Linux Bash shell script has support for regular expressions. So let's get into it. So in Java, going all the way back to some of the earliest versions, regular expressions were a feature of the language and available. They're available through the J2SE standard edition. So basically, there's a package you want to look at, java.util.regex. And regex, R-E-G-E-X, that just is a programmer's abbreviation for regular expression, which is what we're talking about. And there's some relevant classes in that package. One of them is pattern. Pattern, you want to look at the Java doc for that class, the API documentation, because there is extensive documentation on how to use regular expressions, how they work, how to use the Java classes associated with them, but then more importantly on the syntax. So when you write a regular expression, you're writing a little string, a little piece of text, a string, that adheres to a specific syntax. In other words, it follows its own sort of meta language within Java. And it is almost its sort of own little programming language. Although there's not really much logic involved with it. It's more about defining a sequence of characters, a matching pattern to look for in a string, in a set of characters. So basically, a regular expression is used by certain Java classes to test whether it can find the pattern that you have defined within a test string. So let's take a look at that. Here I have open the Java doc or the API doc for the pattern class, and that's really the best place to go to for the regular expression documentation. And it's too much for me to cover individually all of the syntax rules and the individual tokens and what they mean and so forth, but you see how much it is right here. But if you look at this API doc, it will cover pretty much all of it. So there are certain operators that match on whole classes of characters. You know, you can match literally, meaning you can match, if you want to match the letter Z or the letter K, you can do that by, in your regular expression, just include the letter K. But other times you want to match on a whole class of characters, like let's say digits, numerical digits. And so there are certain operators for doing that in the regular expression syntax. For example, here, /D, \D, that represents a digit. If you uppercase the D, that represents a non-digit, but digit being 0 to 9. If you want to match on white space characters, that's a \S. Non-white space is \S. A word character, that includes all alphanumeric, so all digits, underscores, any character that could be included in a file name, like say a Windows or Linux file name, that would be a word character, and that's where you would use \W. Now it's much more extensive than that, but there are a couple other operators I do want to focus on because they are key. There's this one, the sort of upper array, that represents the beginning of a line. So let's say you want to, this is useful because sometimes you want to test that an entire string matches your pattern. And then other times you want to test that an entire string contains some pattern. So sometimes you only want to see if it contains a pattern somewhere in the string as a substring, and sometimes you want to see if the entire string matches. So when you want to test whether the entire string matches your pattern, your regular expression, you would begin your regular expression with this character to denote that the line begins there. And you would end it with this other character, the $sign, that's the end of a line. Other key characters that or operators that I want to focus on, let's take a look here, are the reluctant and possessive and greedy quantifiers. You can read into when you would use each, but for all of them, they kind of follow the same pattern. When you want to test that a given character, you want to make it an optional character, meaning it may appear once or not at all. You follow it with a question mark, so question mark afterwards. When you suspect that it may not appear at all, or it may appear multiple times, like more than once, 0 or more times, that's the asterisk. When you know that it will at least appear once, but maybe more than once, that's the plus operator, that's 1 or more times. When you want to test that a given character appears an exact number of times, no more, no less, then you specify open and close braces afterwards, and you provide the number. Like 3 times would be a 3 inside curly braces. And then it gets a little more nuanced. If you want to test that a given character occurs at least n times, you would use this form. Open, close, curly braces, the minimum number, and then a comma, and then nothing. So that indicates that the lower bound, or the lower limit, is n. If you want to test that it's inside the number of occurrences of characters inside a certain range, then that would be this syntax here, and I'm sure it makes sense, that part. But if you've worked with regular expressions in any other language, you probably see that these operators and these characters that I'm going over now are the same in pretty much every language that supports regular expressions. Now let's go to a simple example. Inside the java.util.regex package that I talked about, one of the key classes is the one we're reading right now, class pattern, and that's useful. We'll show you a code example of using that later. But then there's also another key class, which I'll link to from here, which is the class matcher, and you can start reading the documentation about that. Let me go to that. Scroll down. Okay. Here is class matcher. That's also in the same package. That's when you would use a pattern to supply it. You would supply it with a string regular expression, and you would instantiate a pattern using a factory method. Once you have a pattern, then you take that pattern and you apply test text to it, meaning a string that you want to check. You want to scan with the regular expression. And you do that, you get a matcher. The matcher is a class that allows you to browse through the groupings of the matches, or the results. Because the results are a little complex here, you can use this matcher to just get a simple true-false, meaning does the pattern even appear at all, and if it does, true. False otherwise. Or you can get more nuanced. Do you want to return the exact match? In other words, did it detect a phone number? If so, then return the actual phone number that was found. So forth. Did it detect an email address? If so, return the email address that was found in this case. And you can do all that nuanced stuff with a matcher. You can even get into individual groupings, meaning using the matcher in the right way. Let's say it detects phone numbers using a regular expression you write for phone numbers. Well, if you write your regular expression in the correct way, you can define groups within the match, meaning let's say you want to extract the area code of the matching phone number. Well, when it gets a match, you can use the matcher to extract the correct group, and you can therefore extract what was the actual area code in the matching phone number that was found. Now, if you're new to regular expressions, none of this will make sense yet. So we'll go to a practical example. And for that practical example, I'm going to skip using pattern and matcher because they're kind of complex. They're more advanced. We'll focus on the string.matches method. So you guys have probably run into this method before, which is available for strings in the string class. It's the matches method. And it allows you, if you have an existing string, to match it against a regular expression that you provide. You provide the regular expression in the form of a string, and it will test whether the first string, this string, whether it matches your regular expression. If it does, it returns matches. The matches method returns true. Otherwise, it returns false. So let's go to a specific example in code. Okay, sorry about that. I had deleted it. Okay. So in this test method, in this main method, I've got some check text, meaning some text to check against our regular expression. You see that this text is a string, and it's in the form of a US phone number. So we're going to be testing for using regular expressions to test for valid US phone numbers. Now, of course, this isn't about Java calling the phone number and verifying that someone answers. This is about verifying that the string itself has the correct pattern, that it looks like a phone number. It matches the pattern or the format or the syntax of a phone number. And who defines that syntax and that format? You do as the programmer. And you do that here by defining a regular expression, which is what I've done in line 12. Like I said, you're defining a string. It's beginning, opening and close quotes for a string. And I've just done that as a string literal here. And inside these quotes is the pattern that I want to match for. This is where I have written a regular expression. This selected here is a regular expression representing the pattern of a phone number. And I basically wrote this myself. It's a simple example because it's not meant to be infallible. It's not meant to be 100% perfect regular expression for matching phone numbers. The reason is there's a lot of variation in the way Americans write U.S. phone numbers. Some of them use parentheses around the area code, some don't. Some use a hyphen between the prefix, which is the first 3 digits, and the rest. Some don't use that hyphen. Some use a dot instead of a hyphen. Some use a dot instead of parentheses. So it gets very nuanced, and it's all personal preference. You can, in your code, in your program or your web application, let's say you're validating phone numbers that a user has entered into a form. Well, you can be as stringent or as comprehensive as you decide to be. And it's all about how good you are at writing all-inclusive regular expressions that don't return false negatives. So in other words, let's say you want to cover for all the people that, all the different ways that a phone number may be written, a U.S. phone number. Well, if you're really good at writing regular expressions, you can cover all of those different ways, or in theory you can. You can write a pattern that covers every derivation and every deviation from the norm in writing a phone number. Now, for this tutorial, I wanted to keep the regular expression itself simple so that I can explain it to you. And I don't want it to get too long and too complex. And that's what I would have to do. I would have to make it very complex in order for it to be all-inclusive, in order for it to be a more perfect regular expression that matches any variation of a phone number. Therefore, I've made this regular expression more stringent, and it expects the phone number to be within a well-defined and a narrow range of variation. So let's go over the regular expression here. I've defined it as a string. You'll see a lot of occurrences of these double backslashes. That may stand out to you. Double backslash here, double backslash there. Now, I want to simplify things and let you know, anywhere those occur in this regular expression, it's just an escape sequence. It's designed to escape the character that follows it. So in other words, you see here that there's a double backslash before the D. And elsewhere there's a double backslash before this S. That's just because the double backslash escapes the S or escapes the D, meaning it's telling the system to not treat it as a literal D. It's not to look for a literal letter D, but rather to treat it as a code. And that will make sense when you read the documentation for regular expressions, because you know that we talked about D, or backslash D, represents a single digit, 0 through 9. And S represents a single white space or a tab, any kind of white space. So we want to make sure that our regular expression isn't trying to test for an actual letter S or a letter D. And so to do that, we must escape it using the double backslash. So that's what that is. Now, if I ignore the double backslashes and review what I've written in this regular expression, it'll make a lot more sense. I've got an open paren, and I've put a question mark after it, which is the optional qualifier. That indicates that optionally there may or may not be an open paren. Then skipping past the escape backslashes, there's a D, and I followed it with this sequence, with this form, which indicates that there should be exactly 3 digits. The D indicates digit, and in curly braces I've indicated there should be exactly 3 digits. So that covers the area code in the open paren, and then I follow that with a closed paren, which I've made optional. So that's the entire area code, and optionally any parentheses that are enclosing it. You see that I then have a backslash S to match on any optional, with this question mark, optional white space. There may be one white space or none at all. That's what the question mark signifies. Follow that by exactly 3 digits, followed by an optional hyphen or minus character, because some Americans use that to delineate between the prefix and the suffix, followed by a sequence of 4 digits, and that's this here. So the regular expression that I've written here should make a little more sense. And like I say, doesn't cover all various ways of writing phone numbers in the US. However, it covers most of them, the most frequent way to write it, and it allows me to keep this regular expression rather short and easy to explain without it getting too elaborate and hard to understand. Now, if I were writing a regular expression like this to test for phone numbers in a real application for production, I might actually get more nuanced and elaborate and make the regular expression might be twice as long to cover for all the different variations that one might encounter. But in this case, for the tutorial, I kept it simple. And then all I do is I call the string.matches method, the built-in method of class string that allows you to test whether a given string matches a given regular expression. And so I call it on our check text. Check text here is the phone number, and I call matches supplying the regular expression that I've defined here. That should return true if our pattern matches this text, if it actually matches a valid phone number pattern. Otherwise, it will return false, and it system outs the appropriate message. If it's true, it outlines that it's a valid phone number. Otherwise, it outputs that it's an invalid phone number, not a valid phone number. So if I run this, you'll see that it works. It matches the phone number. Okay, it ran, and you see in the console here that it indicated that this is a valid phone number, meaning that our test worked, and it shows the happy path that a regular expression can be used to test whether a given string matches this pattern of a phone number. Now let's test the error path, and let's see if we alter this so that it's not a valid phone number. Let's see if it fails, if we get a negative. So let's try something else here. I've deleted the area code, I've changed the number of digits, I've put in some alphabetic characters, letters. So let's try that. Let's see if that matches. It should not match. And fortunately, that's what we get. This is not a valid phone number. So you see it at a rudimentary level. In theory, we've got a way of validating phone numbers now. Now, I wrote a regular expression that matches on phone numbers, but you can write a regular expression to match on any kind of pattern. So you could use this for validating the correct format for an email address or a street address or a social security number. The list goes on. You can even look for specific sequences of words within text. And the string.matches method, it takes a string. You could supply this string from an input stream or from a submitted form or from post parameters from a web form that a user posted. So you see how this could be used. But however, string.matches is the most simple and the most limited way of using regular expressions. There are more advanced ways to use regular expressions that are more powerful, so we'll go into those next.